SK sir. Today I am going to discuss on topic valency. It is defined as it is the combining capacity of an element that present in outermost shell of an atom. It is denoted as small v. Now in previous video I discussed about the valence electron. Then before seeing this video you have to see first valence electron, then you clearly understand these matters. Now we come to the point. Here some conditions are given in which number of valence electron, suppose that if number of valence electron is 1, then its valency is also 1. So we see, suppose that we take hydrogen, we know that Z of hydrogen is 1, so we write its electronic configuration 1s1. In hydrogen element, valence electron is 1 here, so valency is also 1. Now we see next condition. If number of valence electron is 2, then valency is also 2. Now we see in beryllium, Z of beryllium is 4, so we write electronic configuration 1s2, 2s2. In beryllium element, now outermost shell of the element is 2s2 and number of electron present in 2s2 2, so valence electron is 2, then valency is also 2. Now here clearly shown. Now we see next condition. Now if number of valence electron is 3, then valency is also 3. Now we see here in boron, we know that Z of boron is 5, so we write electronic configuration 1s2, 2s2, 2p1. Now we have to first sort out here outermost shell of the boron element and number of valence electron 2 and 1, that means 3. So valence electron is 3 and valency is also 3. Now in this way we derive valency of any element. Now we see next condition in which if number of valence electron is 4, then valency is also 4. Now here we use octet law in which we reduce the number of valence electron and derive the valency. Now we see in carbon atom, now 1s2, 2s2, 2p2. Now in carbon element, outermost shell is 2s2, 2p2 and number of valence electron is 4. Now here we use octet law by which we derive number of valency. First we see that the valency is equal to 8 minus 4 is equal to 4. Then here valency is also 4. Now we see in next condition, if number of valence electron is 5, then valency is 3. Now we derive it. If we take example nitrogen element in his electronic configuration 1s2, 2s2, 2p3. Now here outermost shell of the nitrogen element is 2s2, 2p3 and valence electron 2 plus 3, that means 5. And now by using the octet law, here we derive valency is equal to 8 minus 5, 3. Here valency of the nitrogen is 3. Now if number of valence electron is 6, then valency by using octet law 8 minus 6 is equal to 2. So we take example of oxygen. We know that Z of oxygen is 8. So 1s2, 2s2, 2p4. Now outermost shell of the oxygen is 2s2, 2p4 and number of valence electron 2 plus 4, 6. Here valence electron is 6. So by using octet law, valency is equal to 8 minus 6 is equal to 2. Then valency is 2 in oxygen. If we take another condition, if number of valence electron is 7, then valency is equal to 8 minus 7 is equal to 1. So we take fluorine. Now we know that Z of fluorine is 9. So 1s2, 2s2, 2p5. Now we know that the outermost shell of the fluorine is 2s2, 2p5. So here valence electron 2 plus 5 is 7. So valency we derive by using the octet law. Valency is equal to 8 minus 7 is equal to 1. Then in this way we derive the valency of any element. Now next condition we see, if number of valence electron is 8, then by using octet law we derive valency is 0. Now here we take neon. We know that the Z of neon is 10. So 1s2, 2s2, 2p6. Here outermost shell of the neon is 2s2, 2p6. So here valence electron is 2 and 6 is equal to 8. So valency is equal to 8 minus 8 is equal to 0. Then in this way we derive valency of any element. Now using this, how to derive valency? Now here some elements and its valence electron are explained. We have to derive one by one. By these informations we got valency of element. Now we see first in hydrogen element how to derive valency. If you have given as an example, here we know that the Z of H is 1. So its electronic configuration 1s1. Now we know that its outermost shell and innermost shell 1s1. So here we accept as a outermost shell. So here valence electron of hydrogen is 1 and valency is also 1, because I saw in condition 1, if number of valence electron is 1, then valency is also 1. We see the next example. Helium. We know that helium, it is a noble gas. We know that Z of helium is 2 and electronic configuration 1s2. So its outermost shell is 1s2. Then its valence electron is 2, but valency is, by using the duet law, 2 minus 2 is equal to 0. So in helium its valency is 0 because it is a inert gas, as known as also noble gas. So here valence electron is 2 but valency is 0. We always keep in our mind. Now we see next element, lithium. We see that lithium, we know that Z of lithium is 3 and its electronic configuration 1s2, 2s1 and its outermost shell is 2s1. So valence electron is 1 and valency is also 1. Now we see the next element, beryllium. We know that Z of beryllium is 4, so its electronic configuration 1s2, 2s2 and its outermost shell is 2s2 and number of valence electron is 2, then valency is also 2, because we saw in condition second, if the number of valence electron is 2, then valency is also 2. Now we see next example, boron. We know that Z of boron is 5, so we write electronic configuration 1s2, 2s2, 2p1. Now outermost shell of boron is 2s2 and 2p1 and number of valence electron present in boron is 3. Then we know that if number of valence electron is 3, so valence is also 3. Now we take another example, carbon. We know that it is known as a non-metal, so here we use octet law. Now we know that Z of carbon is 6, so we write 1s2, 2s2, 2p2 and its outermost shell of the carbon is 2s2, 2p2 and number of valence electron is 4. So we use octet law. So valency is equal to 8 minus 4 is equal to 4. In this way we derive valency is 4. Now we see in nitrogen, Z of nitrogen is 7, in which its electronic configuration 1s2, 2s2, 2p3. Now we know that outermost shell of the nitrogen is 2s2, 2p3 and number of valence electron is 5. So here valency is, we know that 8 minus 5 is equal to 3, because it is also a non-metals. Now we see in oxygen, we know that Z of oxygen is 8, So we write electronic configuration 1s2, 2s2, 2p4, and its outermost shell of the oxygen is 2s2, 2p4. Now valence electron of oxygen is 6. Then be using the octet law, 8 minus 6 is equal to 2. Then its valence is 2. Now we see in fluorine. We know that Z of fluorine is 9. So we write it electronic configuration 1s2, 2s2, 2p5, and its outermost shell of the fluorine is 2s2, 2p5. So its valence electron is 7. Now by using the octet law we derive valency. We know that 8 minus 7 is equal to 1. So valency of fluorine is 1. Now we derive the neon. We know that Z of neon is 10. So we write electronic configuration 1s2, 2s2, 2p6, and its outermost shell is 2s2, 2p6. And here number of valence electron in neon is 8, and by using the octet law we derive valency of neon 8 minus 8 is equal to 0, because it is a noble gas, as also known as the inert gas. So we derive valency of element in this way. Now any element we can easily derive valence electron and valency by using these conditions. If you like this video, give comments. Thanks for watching this video.